Hi friends, welcome to Jitesh classes. Today, current electricity part 2. We are starting live classes from today. Some will be live classes and some will be normal classes. And now, current electricity part 2. And please share the video on your Instagram, FB and other social media, other social media, other social media apps, and please share the video. Now, I'll recall the last chapter what we talked about. And if you didn't saw that last chapter, the link will be provided in the description immediately after the video live stream. And now what we talked about, what we discussed in last session, that one is what is electric current. Introduction to electric current. It means what is electric current we discussed. The electric current is charge, the rate of flow of charge per unit time in a conductor. Means the rate of flow of charge per unit time means I is equals to Q by T. Then what happens? I is equals to Q by T, and direction of the current is always in the direction opposite to a flow of electrons. And one important thing I said, that take a misconception from your mind that when we attach, means when we will connect electrical appliance to a power source like battery and other which are containing energy, then what happens is the electrons will not flow from the power source and they will not generate electricity. The thing is, the energy provided by the power source is pushing the charge, and due to that energy pushing the charge, then what happens? The force is acted due to that displacement, and that leads to flow of charge. The rate of flow of charge is electric current. And the thing, the charge is never accumulated, it is conserved. Means neither be created nor be destroyed. Means how much is entering, that much will flow. Nothing is inside the nothing is means gathered, nothing is collected, nothing is stored in it. The conductor will be the conductor will not accumulate, it will conserve the charge. And now we are starting current density. Current density in a conductor. Current means it says us that the area, the current flow is also depending upon area. Area means if we take a conductor, see, if we take a conductor, in that what happens, the current is flowing. Means if in a conductor, that if this here, see, from this point, in different points of the conductor, the current flow is different, the current flow is not same. If you can understand when it is when the current flow is compared, with the flow of current. See, I'll explain. Think if this this is a pipe. In this pipe the water is flowing. Then what happens? The see, water is flowing. If we block this completely and a small hole, from that how much? See, don't compare it to the accumulation of the current. It means that accumulation means how much is entering, that much will go. If we'll see from there, this is a big one and this is a small one. How much is entering from here? Even if it will how much is entering from here, even it may take more time, but it will go. Okay, keep it aside. And now this one, okay, water is flowing inside, and if we take a small point in this, the water flowing through the whole pipe is not equals to the small point in it. Understood? Similarly, see, again once I am repeating that in this pipe at different points, means if see, in this conductor, this is a conductor, in that, in this cross sectional area, this is a cross sectional area, means it is the cross sectional area is always this cross sectional area is equal to the conductor cross sectional area, it is a uniform conductor. Then what happens? The current flowing is same. If 10 ampere is flowing, then from this point also 10 ampere is flowing. But in the same conductor, if we will take this much part, then from that the 10 ampere current is not flowing, somewhat less than that, because the area is different means this is big. See, this is complete and this is small one. Through that small one, it is not, the same current is not flowing. Understood? If you didn't understood, go back and see again once the video. And now, current density is the flow of current per unit area. Means the current density is there, no, that is flow of current per unit area, which is normal to the area. Normal to the flow of current means the area is there, no, this area is not, the current is flowing in this direction, and that area is normal. It means it is perpendicular to the flow of current. It is perpendicular to the flow of current. Okay, and if di is the current at a point, sorry, if di is a current at a point, see, at this point di current is flowing. If di current is flowing, or we can take the net flow of, because that is the whole area, no, the net delta I and delta A. In that, then what happens, the J, it is denoted by J, the current density is denoted by J, and that delta I and delta A, no, this is the current per area, delta I by delta A, and delta area is a vector quantity. Keep in mind about that, area is a vector quantity. Delta I is moving in this direction, and delta A is the vector in this direction, vector quantity. So J is a vector quantity. Here also see the formula, at an instant, I already explained that I is instant at I instantaneous is equals to di by dt. Similarly here also, J at a particular point, di by dA. di by dA is the current flow at a particular point. J is a vector quantity, and direction of the see, J is a vector quantity, and direction of the density, current density is always in the direction of flow of current. See, if the current is flowing in this direction I, then see, I'll explain the perpendicular when the area is not perpendicular. I'll explain that in next. I'll explain next. Wait, we'll discuss about it. But in this, see, this is cross sectional area. If this is perpendicular, then if the I said already, current density is in the direction of flow of current, means it is perpendicular to the area, means it is taken as perpendicular to the area. Once guys, I am not seeing your live chat. Once wait. Okay, Karthik Reddy, thank you. Sudharani, hi, and Shanmukh, hi, and Swami, and hi everyone. And okay, SI unit is the area per meter square. SI unit of that means delta. Once wait. Delta I, the unit of delta I is ampere, and the area, SI unit for area is meter square, and the SI unit is area per meter square. That is the current density. Current density means, once again recalling, current density means the flow of current rate. The flow of current, it is depending upon the area of the conductor, or it is not equal at different points. See, at different points on a conductor, the current flow is not equal. It is different. It is varying. That will conclude in the current density, and the unit is SI unit is area per meter square, and the formula is di by dA, and it's a vector quantity. Keep it in mind. That's it on this one. And the problem, I'll say about this sums in some DPPs. I'll also conduct the DPPs. In that means daily practice problems. On that I'll say important problems in that. Okay, and now we are starting drift velocity. Before that, I'll say a question. Okay, I'll say a question on this current density. Wait guys. wait a minute. Okay, I'm seeing you live chat now. See, current density. When a problem on it, when the current flow is in a conductor, current flow or I. Wait. Okay, wait. I is equals to 6 milliampere. I forgot the units. I'll say in dB per section. Milliamperes, microamperes, those are there. Okay, milliampere is equals to 6 into 10 to the power of minus 2, I think. Wait. It's 0.006 ampere, and that is equals to 6 into 10 to the power of minus 2 ampere. That's it. And another thing, what is the area? Area is given that 4 millimeter square. Millimeter square is 0. That's also 0.04 meters is equals to 4 into 10 to the power of minus 2. That only na meter square. Sorry, that's millimeter meter square, and this is meter square. Now, what is current density? I by A is the current density, and 6 into 10 to the power of minus 2 by 4 into 10 to the power of minus 2. Okay, this is current density. Hi Dileshwar Rao. Hi for you also. You can ask doubts in the live chat, okay? And those two will get cancelled, and 0. How much? 3 by 2. 3 by 2 only, 2 and 3. Yeah, 3 by 2. 1.5. Ampere a meter square. That one correct only. Is it correct? I saw that. I is equals to, I is equals to 6 milliampere square. Milliamperes means it is equals to 6 into 10 to the power of minus 2 ampere, and 4 into 10 to the power of minus 2 millimeter square. And next J is equals to that we got. That's the value. And guys, now we are starting drift velocity. That's drift velocity. Drift velocity. Drift velocity. What is drift velocity? There's no particular definition for that. And now see, drift velocity is denoted by Vd. It is equals to Vd. This is a conductor. This is a conductor. Guys, how many are watching now? Just 4 are watching now. Please take it up to 10, 20. That's our target today. And now drift velocity, that is denoted by Vd. That is denoted by Vd, drift velocity. And if in a conductor there are positive ions. See, if in a conductor atoms will be present. In that atoms, when they'll lose an electron, like Na positive and those all iron, Fe 3 plus, like that, they'll lose some electrons and they'll become positive. Means they'll become positive ions. When they'll become positive ions, they'll be fixed at a point in a conductor like this. They'll be fixed at a point. Means they are called lattice points. In chemical bonding you will learn. They are called lattice points. And these electrons, which electrons are loosed, those electrons will perform the nature. When they lose an electron, they'll gain positive energy, and due to that they are called lattice points at that point due to the positive ionic charge. Then what happens? Positive ionic charge. What happens? The positive ions will be fixed. Then those are called lattice points. And those electrons, in a conductor we know, in a metal, these electrons are negatively charged and positively charged, both will be, and these will perform random motion because the electrons nature is to do random motion, so they will do random motion. They will do random motion like this. They will do random motion in some path like this from then you'll think that means from positive to negative terminal, or you'll think okay, when it is not here, see, I forgot, this is absence of battery, absence of power source. Power source means power source is not connected to it, means the absence of power source, electric field is not there. If electric field is there, that will exert a force, apply a force on the on the charge. So they will do random motion. You may think that there is no energy, no, from where they'll do random motion, where they'll get velocity from, means the heat, the heat is there, no, that heat will apply some force on it. Due to that force, they will undergo displacement. Due to that displacement, velocity, and that thermal velocity, you may think that is a small quantity, that may be small quantity, but that is nearly up to 10 to the power of minus 10 to the power of 5 meters per second, and not so much needed on it. You may you can, in textbooks it will be in reference books and those. Thermal velocity, it will go on thermal velocity. It will attain a velocity due to the force of thermal, means due to the heat energy, the force is applied, and due to that they will do velocity that will be nearly equal to 10 to the power of 5 meters per second. And now these electrons are there, no, they will do continuous collisions with these. They will do continuous collisions with these positive ions. What happens due to that continuous collisions for some time, means this is a positive ion, means these are positive ions, or think my fingers are positive ions, and these electrons are there, no, it will go like this, and it will do random motion, so in some direction, and it will do random motion in the direction, in different directions. So due to that continuous collisions, the energy at some extent will be done, it's done, and with the electric will be decreased a lot. Then what happens, where that energy will get from? And now the results of these, when they will do continuous collisions, means they are doing random motion, no. At the time of random motion, the u1 plus u2 plus so on up to un is equals to 0. That's, and we need average of every electron, no. So by n, how many electrons are there? u1 plus u2 plus u3 so on up to un is by n is equals to 0. Clear up to here? And next, due to the electrons random motion, the current is not there. Current, see, when they are doing random motion, if it is absence of battery, even it is absence of battery, due to the charge, due to the energy, they may need some, they will get some electric current, but they are not possessing the electric current due to the random motion of electrons. Okay, the random motion of electrons. That's why when it is not connected to a not connected to a power source, the electric field is not present. Clear up to here? Means zero current. Okay. Now again, see, zero current when it is connected to a battery. This is the important point where we will derive the equations which were needed. Okay, you are clear up to there, where the energy will be done. It's done. Energy is done. Then they will get energy from like God. It will the see, means you can connect it like when the electrons are doing random motion, means when a teacher is not there, the students will do roam this and that's it. In the same way, those electrons are not, they are doing random motion in different directions, and the resultant un means u, what is called that's called as u starting u will be velocity, average velocity on these, those all will be random motion, due to the resultant velocity will be 0. Average resultant velocity on in any direction is 0. And now when these electric current or battery, or it is connected to a power source, then what happens? The electric field, due to the electric field from positive to negative, say it is going from this side, so positive to negative, these positive ions are present. When the electric field is there, it's you can compare to when a teacher came, when a strict teacher came to the class. As that way, electrons will move in this direction. When that current is moving in that direction, electrons are moving in this direction, or any direction you may take. That's your wish, up to your wish. They are moving in a direction, no. When the electrons are moving in the same direction, then the energy, they got the energy. What happened when the absence of battery, the electrons are moving in random motion, and for some time the energy is gone. The energy is gone. Then what happens? The battery, the power source will apply some energy on that. It will give the energy on that. Due to that, the electrons will get pushed, will get continuously pushed, and will get continuously collided with the positive ions, and will get continuously pushed. Due to that due to the electrons energy is applying, due to that energy, what will come? Due to that energy, force. Due to that force, displacement. If when a force is acted, if this is a particular person or an electron, when it is energy is done, if it is moving, if an energy electric field is acting on this, what happens? It will undergo a displacement. When I undergo a displacement means when force is acted, it will move. Then what happens? The velocity will come. That's called the drift velocity. How simple I explain, see. That's called the drift velocity. Vd. And now first we will derive the force. Okay, the force, some force in the opposite direction, in the direction of the current. Okay, means see the current is in the direction and the electrons are moving in this direction, and the force will be in that direction. Means the electric current flow in this direction. Okay, easier, simpler. And F is equals to QE. In electrostatics, that will be after, I will say in next chapters. EE we'll get first equation, keep it in mind. And F is equals to MA, we know another one. F is equals to MA. Then what happens? MA is equals to EE. MA is equals to EE, and A is equals to EE by M. A is equals to EE by M. Okay, and then what happens is we need the drift velocity. This is clear. Is this clear? If you didn't understood, again pause the video. Again take the video and again watch the video. See. The A is equals to EE by T, and we got VD is equals to U is U1 plus U2 plus U3, so on up to UN by N is equals to 0, and that's resultant, average resultant. Or we can take from it is starting with an initial, then it's 0, or that in that case also we can take, or in the case when it is absence of battery, and that case also we can take. So U plus AT. And one thing, the T is the relaxation time. Keep it in mind. T means that will be denoted by tau. I'll explain now what is relaxation time and what is that. T is equals to relaxation time. Relaxation time. This is a positive ion. There is an electron. Or this is an electron. This is a positive ion, electron. Then what happens? The electrons are colliding with the positive ions. What happens then? Colliding with positive ions, these electrons will get, means two successive collisions, means 2 or n successive collisions. When the electron, the average time, or we can say, see, correct definition I am saying, the average time of two or n collisions, successive collisions with the positive ions, means this is an electron, it hit this and somewhere it is going and again it is coming, like that. Some not only with the same electron, the means 2 or n successive collisions, means tau is equals to T1 plus T2 plus 3T, means when they are hitting that, the time taken, then the time taken, that average for n collisions, n successive collisions is tau. That's the relaxation time by n. It's the tau and relaxation time. It's the relaxation time, and we know u plus at, 0 plus a into tau. A into tau. That's clear. Keep in mind that's the relaxation time. It's also one of the important term in drift velocity. And Vd is equals to E by m into t. Tau is the relaxation, is the drift velocity, and other drift velocity is also there. This is in NCRT. We should follow in board exams or some. This is an important point. NCRT. This formula is in NCRT and in some reference books like H.C. Verma sir also explained about it. The link will be provided in a video he explained. The link will be provided in the description at immediately after the live stream. And this is NCRT. This will be in NCRT. Means and next one also I'll explain that. It will be by 2m. See how it will be. See, it will be V average, means this V average is taken as the drift velocity of the average, all the average velocity of these electrons, all electrons. Then it will be V plus U plus V by 2. Then Vd, this is V average, means V drift velocity average of all electrons is taken. So this one means drift velocity is the when in a metal conductor it is connected to a battery or power source, what happens, the electrons get continuously pushed due to an electric field, then the velocity which is acquired by it due to the, after the energy was lost by it, then what happens, due to the electric field applying an energy on it, the force, due to that force it will undergo a displacement, and that leads to the velocity, and that velocity is called the drift velocity. Okay, and that's okay. Average of all electrons. Then what happens? Vd is equals to U plus V, 0 plus V is equals to U plus at. That's also 0 plus a tau by 2. Then Vd is equals to A is equals to E by em. E by m. We know E by m 2m. This will be by 2 Then anyways into 1 by 2. Then 2m by 2m into tau is the drift velocity. This is by taking different assumptions. This is also by taking assumption of that we got the formula, we derived that. This is also by taking assumption. His point of view is m and 2m. Means the mass of the electron is negligible. M is mass of the electron, means the mass of the electron is negligible. So we can take m or 2m. That's his idea, point of view. And another case, relation between Vd and J, current density and drift velocity, will be explained in the next video. And this is up to here. Once again, I'll recall what is current density. At different points, the current flow, means different points, the area, different areas, the current flow is not same. That's different. That is current density. Means it is depending upon the area. Is di by dA is the formula. That's the formula. It's a vector quantity, and the SI unit is area per meter square. And next, this drift velocity, when it is connected to a metal conductor, already explained 2-3 times up to now, and this is the last time today of this session. And velocity, drift velocity is denoted by Vd, and that Vd means when a conductor is connected to a battery or a power source, what happens? Before that, when it is absence of the power source, due to some thermal energy provided in it, due to the heat, the electrons perform random motion with the thermal velocity. It is up to equals to congruent. It is up to means it is nearly taking to 10 to the power of 5 meters per second, and it will move with it up to some time. Then what happens? The energy will be decreased. At that time, if the electric field is applied, means if we connect it to a conductor, what happens? The electrons will get continuously pushed. Means why that will lose starting, why that will, when it is absence of battery, why that will lose the energy, due to the continuous collisions. Then in this where I stopped, that nearly when the current is applied, the electrons will get continuously pushed and collided. Even though collided, the energy is applied, no, and that will undergo a motion, means force, that will will be exerted a force, and that force is will leads to the velocity of the conductor, velocity of the electrons in that, and that velocity is the drift velocity. Formulas I have derived. Okay. If you like my explanation, kindly like, share and subscribe to my channel, and some other live streams will be conducted in upcoming videos. Okay, bye. Thank you.